Welcome to This Explainer. Today, we're diving straight into the fascinating detective work that AI actually has to perform just to understand the simple identities hidden in our everyday sentences. I mean, when we read a paragraph, we effortlessly keep track of who is doing what, right? But for a machine, tracing a simple pronoun back to its owner is literally one of the most complex puzzles in natural language processing. So today, we're going to unpack exactly how modern algorithms solve that puzzle. You and I, we grasp what pronouns mean without even thinking about it. But for a computer, resolving a word like it is a complete and total mystery. It's actually brilliantly illustrated by this excerpt from Lewis Carroll's Alice in Wonderland, where the duck hilariously gets completely confused by the word it. Well, for an AI, every single pronoun is essentially exactly that confusing. It sees a word like he, she, or it, and has to launch a full-scale investigation just to figure out what thing or person that word is actually pointing to. To solve this mystery today, we're going to follow a problem-solution arc. We'll start with number 1, the pronoun problem, then move to 2, spotting the mentions, 3, scoring and ranking matches, 4, linking to the world, and finally, 5, common sense and bias. Let's get right into it. Section 1, the pronoun problem, the mystery of she and it. Let's look closely at how humans can just effortlessly track identities across a text and why it's such a foundational hurdle for these algorithms. Okay, let's dive into this sentence. And I want you to actively ask yourself, who exactly do the words her and she refer to? It reads, Victoria Chen, CFO of Megabucks Banking, saw her pay jump to $2.3 million. It is widely known that she came to Megabucks from rival Lotsabucks. For you and me, it's totally obvious, right? She and her are Victoria Chen. But the computer, it just sees a string of text. It has to mathematically prove that connection. Now, linguists actually have a name for this connection. They call it anaphora. You can think of an anaphora as a pointing expression, like a pronoun, that looks back at its original owner, which we call the antecedent. So in our Victoria Chen example, she is the anaphor and Victoria Chen is the antecedent. Whenever two expressions refer to the exact same entity, we say they co-refer. The whole shebang of Coreference resolution is basically finding all these links and grouping them into organized chains. What's really cool here is how we can visualize the AI building what we call a discourse model. You can think of it as the AI's mental map. As it reads through the text, it evokes these distinct mental entities into the model. You've got Victoria, the person, Megabucks, the bank, the actual money. Then, when it bumps into the word she later on, it has to access that mental map and draw a coreference link straight back to the Victoria entity. Moving to section 2, spotting the mentions, gathering the suspects. Our AI detective must first round up all the potential subjects in a text. Before it can link anything, it has to find the spans of text that actually refer to something. These are our mentions. But here's the twist. English is messy, really messy. The AI has to filter out phrases that might look like mentions but actually aren't. Take the word it in the phrase, it is raining. That it doesn't actually refer to a physical object floating up in the sky. It's what we call an expletive or pleonastic pronoun. Or think about the phrase, make it in Hollywood. It is just part of an idiom there. The AI has to be incredibly smart to filter these non-referring expressions out. If it doesn't, it's going to try to link them to real people and objects, and that will cause a massive cascade of errors that could completely break a chatbot's understanding of your prompt. The system also has to carefully log what we call singletons. Take the rival bank Lotsabucks from our earlier example. It's an entity that only appears once in the entire text, 0 pronouns pointing back to it. But it is a vital clue the AI has to catalog in its mental map, just in case it becomes important later on in the conversation. Section 3, scoring and ranking matches, the interrogation. Once we've gathered our suspects, the AI has to interrogate them to figure out which ones actually connect. Let's see how modern systems evaluate these matches. So here's the absolute crucial point. Modern algorithms use a mention ranking model. Instead of just looking at 2 words in total isolation and guessing yes or no, they set up a mathematical lineup. It takes an anaphor, like the word she, and directly compares all potential candidate antecedents against each other. It mathematically evaluates Victoria Chen versus Megabucks versus Lotsabucks, and it ranks them to find the absolute most likely antecedent. Check out the modern neural network approach we use to do this. A really powerful language model acts as an encoder. It analyzes the first word, the last word, and the core head word of a span of text. By passing those representations through a feed-forward network, the AI basically calculates a strict mathematical probability score for every single potential mention in the text. Let's see how this builds up. Once the AI has scored all the mentions, it runs what is known as a softmax probability distribution. Notice how it evaluates the phrase, the company. It assigns a super high probability to General Electric and a much lower one to the Postal Service. Interestingly, it also has a strategic option to choose a dummy variable, called epsilon. That just means it purposefully abstains if it decides there's absolutely no true antecedent in the text. To actually pull this off, the AI relies on an intention mechanism to locate the syntactic headwords within a span, which you can see highlighted here in red. It learns that words like region and area are highly related. But if you look down at the bottom example, you can see it still fumbles pretty hard. It hilariously links the pronoun there to flight attendants instead of the pilots union. And why? Because the word embeddings for pilots and flight attendants are so mathematically similar in the AI's brain, our digital detective makes a totally false match. All right, section 4, linking to the world, escaping the text. So the AI knows Victoria and she are the same within the document itself. But how does it map those text labels to real people and real organizations out in reality? Well, this requires entity linking. You see, understanding that she is Victoria is really only half the battle. If you ask a chatbot a question about Victoria, the AI needs to know which Victoria you mean. Frequently, this is done through a really clever process called wikification. This is a real aha moment for understanding this tech. The AI takes the resolved identity from the text and maps it directly to a massive external knowledge base, usually Wikipedia. Each Wikipedia page acts as a unique ID for a real-world entity, basically anchoring the AI to our reality. Here we can see exactly how a modern neural algorithm, known as ELQ, accomplishes this. Imagine the system gets the question, when did Shaq come to the NBA? The algorithm separately encodes the text of the question and the text of millions of Wikipedia pages. It then calculates a dot product similarity between the two. This is exactly how a search engine flawlessly links your casual, lowercase mention of Shaq to the actual professional profile of Shaquille O'Neal. It escapes the text and connects to the real world. Finally, section 5, common sense and bias, the detective's flaws. Because before we declare this mystery perfectly solved, we really have to drop the curtain and reveal where these incredible AI detectives critically fail. First up, they completely lack physical common sense. This is perfectly demonstrated by the famous Winograd schema test. Just read these two sentences. The trophy didn't fit into the suitcase because it was too large. We humans instantly know it refers to the trophy. But if we change just one single word, because it was too small, we instantly know it now refers to the suitcase. A single word changes the entire physics of the sentence, based entirely on our real-world knowledge of physical space. For a very long time, this completely broke AI logic, simply because algorithms don't live in the physical world. But honestly, even more alarming is the We Know bias test. This exposes how AI blindly inherits our own societal prejudices. When it gets a sentence like, the secretary called the physician and told him about a new patient, the AI links him to physician with incredibly high accuracy. But if the exact same sentence says, told her about a new patient, the AI struggles significantly to link the female pronoun to the physician. The models show a massive drop in accuracy when linking gendered pronouns to occupations that go against historical stereotypes found in their training data. The data makes it crystal clear. Because these algorithms learn to comprehend language by reading massive amounts of our human history in text, they replicate the exact biases present in that text. Which leaves us with this final, provocative thought. If our algorithms must learn to read from us, how do we ever teach them to read without inheriting our deepest flaws? Thanks so much for watching this explainer. We'll see you next time.